like security, like tests, like functional like properties, sustainability has to become like a gate that you have to pass before you can release your software.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. If you're listening to this podcast, I think it's pretty safe to assume that you know that most of the electricity we use to run software comes from electricity grids. And while you can buy green energy from a supplier, and it does help, the actual power that usually comes through the plug sockets will at least partly come from fossil fuels. So if you want to reduce the direct environmental impact of software, the one strategy that you can use is to reduce the electricity that your software is consuming. But how do you actually see how much you're using? This sounds like a simple problem, but it quickly gets complicated. If I'm measuring the energy used by a whole computer, how much should I allocate to my program versus someone else's program? If I'm using a server in the cloud, I might not have access to see the power used by that physical server, or even know where in the world the server is running. If I'm using some serverless platform, what happens to the servers when my program is finished running? Do the servers blink out of existence so I don't need to count them anymore? My guest today, Didi Hoffmann, is the CTO of the descriptively titled organization Green Coding Solutions. And he's been working at the sharp edge of these problems for a number of years now. I saw him present some open source work at Potsdam, an open source conference based in Brussels. And some of it looks like it might help people who are trying to answer these very same questions that I've just posed. So I asked him if he'd come on the show to help me understand the work, and he was gracious enough to say yes. Didi, thank you so much for joining the call. Can I give you the floor to introduce yourself briefly?
Oh, it's an honor. Thank you very much. Yes, as you already said, I'm Gerd Dietger Hoffmann, but nobody can pronounce that, so everybody calls me Didi. And I'm the CTO and co-founder with Arne, who was also on the podcast, I think a year ago, from Green Coding Solutions out of Berlin. And we've been sort of spending our time trying to help companies and NGOs and people in general and to reduce their environmental impact that they produce when running software. A few words about my background. I've been in tech for over 20 years. I'm basically, my upbringing is a C programmer. So I did a lot of Linux kernel development when I was young. So riding the early years of the Linux train, and then sort of progressed into sort of CTOing and managing, let's say. And while on parental leave, I spent a lot of time reading about climate change, because before that I was in the health space. I spent 5 years in Africa doing public health. And on parental leave, I really read about climate change, so saw a lot of the impact we were having through our work. But most of the stuff we're doing was because of climate change. So we did a lot of stuff in North Nigeria, and Boko Haram wouldn't be as strong as they are or were if climate change hadn't happened, if we wouldn't have desertification of lands. So I made the decision to leave health behind me and then move into the climate space. And being a programmer, obviously, I chose to reduce to use the environment, having helped start a few companies in agriculture and building, weirdly enough. Exactly. And we're going to talk about my work sort of measuring in the Linux kernel.
Okay, thank you for that, Didi. So if you're new to this podcast, my name is Chris Adams. I am the Director of Technology and Policy at the Green Web Foundation. That's not the Green Software Foundation, the Green Web Foundation. It's a smaller Dutch nonprofit focused on a fossil-free internet by 2030. I also, rather confusingly, work as the policy co-chair for the Green Software Foundation's policy working group, along with my co-chair, Aya Saeed. We'll add show notes to everything that we discuss here. If there's anything you do see missing, please do email us at the address that we mention at the end. And I think that's pretty much it. Didi, you appear to be cozy and sitting comfortably. Shall we begin?
Let's go.
Okay, so I think you might be the first person who's ever joined this podcast from a homestead or a farm before. So for people who aren't familiar with where you work and what you do when you're not kind of working with Linux kernels, can you describe a little bit from where you're calling from? Because not everyone can see the really cozy fire in the background or anything like that.
Yeah, so the house you're referring to, I live in an old farmhouse from 1620. That's why you can see the fire, because it's quite cold in winter. So next to my passion for computing, I also have a passion for farming. If life would have gone a little bit different, I might have become a full-time farmer. But that shouldn't be, so I studied computer science. And now, I live outside of Potsdam, which is close to Berlin. So I can commute to Berlin, or I can drive to Berlin quite easily. But yeah, we live on our small homestead, and we sort of keep cows, sheep, pigs, chicken, everything. So that if you open a little, like a children's picture book and you imagine a farm, that's pretty much us. With like a small, like we grow our own potatoes and grain and vegetables and all that stuff. And we're eating a lot of apples right now because all the apple trees are full. And what makes us sort of a little bit unique, or I don't know what, like it's all hobby. It's nothing like we don't run a business, right? I think that would sort of ruin the flair of it.
The romance, yeah.
Yeah, exactly. But yeah, it's just great when I sort of like sitting in front of the computer all day, and then you go out and you're in nature and you get to move, and there's always something physical involved, right? Like digging a big ditch or something. There's something always like very active doing, or like one of the cows just got a calf, and so you have to sort of wrestle a calf and put in like ear tags. What we're sort of proud of is that we do everything on the farm. So I always say the animals are born here and the animals are butchered here. Mm-hmm. So my partner and me, we process everything. And so that, I think that's sort of we sort of try to close the cycle, right? We don't just breed animals and sort of put them in a slaughterhouse. And we breed endangered species, which is also sort of an interesting thing, that through the way agriculture is going, we're going to like a few species are reproduced millions and billions of times. But the old species, which have been living here for tens of thousands of years, that genetic reserve is being wiped out. And so for economic farm, you cannot hold us just because the weight gain, the egg laying capacity isn't as high. We can afford to keep these old breeds. So we're organized in a consortium of people where we sort of try to keep old gene reserves. And probably I could go on for hours talking about
it
this.
Sounds like it. So there's a whole like sort of like kind of like even within say agriculture, which is already like the majority of kind of like animals in the world, like by biomass. There is like there's biodiversity there that needs to be maintained, because the default is to just kind of consolidate on a monoculture of a small number of species.
Yes, which are copyrighted. The genes are copyrighted, so you can't even breed the birds yourself, the animals yourself.
Oh wow!
And the main problem is, so these animals are bred for maximum whatever you want to utilize from that animal, right? So with a pig, it's weight gain, or it's for sows, it's how many young pigs they can bring up, or laying hens, it's how many eggs they can lay, right? In how they can grow to the shortest amount, start laying eggs, and then normally it's like 6 to 9 months, and they lay all their eggs, and then they just fall over and die. But the problem is that we've been keeping animals here, let's say humans have probably for 10,000 years been breeding animals, except dogs. And these animals are highly specialized in the environment we live in, right? So if we look at where we are in Potsdam, you have like special cattle breeds that can eat the grass here, right? You can have special sheep that can live on the sandy soils of Brandenburg. Whereas if you go to like let's say the breeding sheep you would normally keep, that couldn't survive here. You'd have to feed it grain again, or soy or something, because the grass isn't as nutritious. So it wouldn't put up in it, or the hooves wouldn't withstand the weather here, right? But obviously those animals produce far more of what you want from them, right? So in an industrial sense, what you do is you just feed something, or you give them antibiotics.
Bring in a feed from somewhere else. Then.
Exactly. So that's why you have these like huge chicken coops where tens of thousands of chicken don't see any sunlight, because they're so optimized for that use case. Broilers, basically, they're optimized to grow so fast that their legs can't hold them. And that's actually something you want, because then they're easier to collect. Right, so when you collect
good
them,
God, wow! I was not expecting to go so deeply into
and so we keep chicken that have been here since 1400 something, or the first mention of that breed is 1400 something, and they're obviously so adapted to the weather, to living here, that you don't need antibiotics, or we hardly ever need antibiotics. But obviously they don't lay 200 something eggs; they lay 160 eggs a year. They don't put on, like, we keep chicken for like 9 months, 6 to 9 months, let's say. A normal chicken's like three months, right? So.
Oh my, wow. Didi, if there ever was a kind of nerdy dream I might have harbored about becoming, like, giving up and working on a farm, I think all the detail you've shared with me has realized that that's not a dream I want to have anymore. Good Lord, there's a lot there.
You should, because that's the only way. If you do it yourself, you know you can do it right?
You fully appreciate it better, I suppose.
You can see, right, what work's gone into it. You can see, like, I think for me at least, I think that's a huge gift, right? That I see where everything comes from, and I see how much work's gone into it, and you really, you really feel the value of what you put into your body, right?
Do you know what? I've never actually thought about someone taking the kind of hands-on, open source, build your own server thing approach to like this part of their life. But it sounds like you appear to be doing a bunch of that as well, actually. Wow, this is a podcast about green software, and it also turns out to be a bonus podcast about animal husbandry and economics of the agribusiness as well. Thank you for that, Didi. All right, that was a lot. Wow. Okay. Let's. I'm just going to switch gears, if I may, to talk a little bit about the last time I saw you in person, which would have been at Potsdam, which is I think it's the largest open source conference or largest tech conference in Europe by kind of attendance, basically. And I never know what Potsdam actually stands for. But you, when I last saw you, you were presenting in, I believe it was the Energy Dev Room, about an open source project called PowerLetrics, which was specifically designed for like making some of this, energy use in software visible. Could you tell me in your own words what this project does and how it came about? Because there's got to be a story there, surely.
Yeah, definitely. So when Arne and me started sort of green coding, we thought, okay, we have to start measuring software, right? And a little naive, we were like, oh, surely there's tools out there that do this. And so what was very important for us is open source, right? As I already mentioned, I come from an open source background, and I strongly believe in open source, and I've always tried to work in open source. And we were like, surely there are tools out there. This is like, okay, we can take this and we can plunk this together, and then we can measure software repeatably. Like, you want to measure it accurately in a repeatable fashion, because otherwise you can't figure out if your change is really responsible for what you're doing, right? And if you can't do that, you're left with a logging tool, right? So we set out writing the GreenMetrics tool, which is our sort of measurement tool, which then developed to a cluster solution, because we figured out, okay, you have to have certain specific hardware, and you have to pin the CPU cycles and to get good measurements. And it sort of ballooned out, and we're still not finished. We're still actively developing. So we talked about a thing earlier, that we were just like sort of looking at network transfer, and we're seeing some. So we're still not finished with the GreenMetrics tool after 3.5 years. But it's in use. It's there. It's a very good product if you want to measure your code and you want to optimize your code and you want to sort of see how your different components are responsible for different usages of resources, let's say. So you can look at your database, at your Redis and whatnot, your front end, your back end, and you can see all the components. But setting it up is sort of, it's not a 1 minute thing, right? You have to think about, what do you want to benchmark? You need to submit it to a machine or a cluster. And so while it's feasible and easy to do, there's a learning curve, right? It's not just there. And so talking to a lot of people, we're like, okay, we need some sort of thing that just visualizes the resource usage of your programs. And then we sort of, in the space, like you have PowerLetrics from Mac, which basically is a tool that you can run, and it gives you sort of energy impact, which is an arbitrary score for how likely your program is to have like an impact on the whole machine. And it's not a joule or something. It's just like if the value is higher, it's worse. And Microsoft has the E3 engine, which actually gives you microjoule, I think, where you can run a benchmarking job, and then it will tell you, okay, this process has used N amounts of resources. And then we looked at the Linux space and there was nothing. And we're like, okay, there were a few things, right? I'm oversimplifying. There were a few things, but nothing
particularly polished, for example.
Nothing, a drop-in replacement that you could just use out of the box. And most things sort of relied on REPL that would just sort of show you REPL readings. And REPL, while being really, really useful, it's only a part of the picture because it's only the CPU. And
when you say REPL, you're referring to basically some of the energy readings from, like if you have maybe an Intel processor inside your laptop, it has its own metrics and it exposes them to this REPL thing, right?
Yes, exactly.
Okay, got it. Yeah.
So most modern CPUs have some sort of energy counter embedded. So AMD and Intel, but AMD even gives you per core, Intel only per chip. And it gives you some sort of energy reading. It's from the power unit of the chip.
Okay, so that's what you're referring to. Thanks.
This is really, really useful because you know how much energy the chip is using. But there are loads of other components, right? If you've got memory, you've got disk, you've got fans, you've got all these other things that are sort of now, and that was just totally, there was no program sort of taking that into account. So we sort of set out, okay, Mac has a good tool that's fairly usable and polished, undocumented and closed source, and you have no idea what it's doing. Some people from Mozilla luckily reverse engineered parts of it. Mm-hmm. But it's still very, like it's a useful tool, but you have no idea what was happening. And Microsoft's the same. So Microsoft, you have there's like a blog post and a video, and that's all there is about this tool. And we're like, okay, like this can't be that you have Linux and Mac, two closed source solutions that have this. They've got at least something, and Linux has nothing polished, let's say. And so for us as a company, it didn't really make sense to develop this because there's like nobody's going to pay us. Like we want to make it open source. We can't consult on this. So we wrote a grant proposal to the Catalyst Fund, and they were really nice, and they funded us.
This is the Green Screen Catalyst Fund,
yes,
right?
Exactly.
Yeah, got it.
Exactly. And they were nice enough to fund the work, to basically port PowerLetrics, which is on Mac, to PowerLetrics on Linux.
Oh, the L and the
Yep.
Now it finally makes sense. Oh,
that's
I see.
The joke.
Okay.
That's the joke. So there's PowerLetrics, which basically is a user-facing program that when you start it, probes the kernel with eBPF, which is a great technology where you can basically put code into the kernel in a secure way without crashing the kernel, without exposing any, how can I say it, without like putting the kernel at risk in any way. So I really like eBPF, and I think it's a great tool to sort of poke around in the kernel and see what's happening. And so we started porting, and so the API is compatible, everything's compatible to PowerLetrics. So we started porting the Mac program to Linux. And we've got that. So you can install that. It's a Python package you can install, and you can get basically fine-grain energy metrics for each process. So it works for a model. So what we do is we attach sort of probes to kernel calls, and we gather lots of data, and then we have a model that basically creates an energy model for the whole machine, as do Microsoft and Mac. So we talk to the people from the companies, and everybody uses the same techniques. So there's no magic anywhere there.
Okay, so it's modeling all. So when you say model here, just to be sure, it's like it's basically a model like you might heard of, like say CO2JS has like a sustainable web design model. Like given these things, I'll give you a number back. It's doing something similar, but at a much lower level based on the signals it's getting from the chip, right? So
exactly,
yeah.
So it's looking at how long has a process run on which type of chip, at which frequency, how much memory, how much disk, how much network. sort of the core. There's not too many signals you can use. I think we have like 20 something signals. And then we have a statistical model, and then it gives you the energy reading for the machine.
Ah, okay, gotcha. And when you're saying process, it's a little bit, it's not quite the same, but you're saying it's a bit like a program. So like Firefox might be one process, and okay, we'll just look aside for that. It probably has lots of other processes beneath it, but like that's.
So you can also look at thread level, right?
Oh,
so
okay,
the model will also give you the energy consumption of each thread. It just depends how far you want to go down. There's nothing stopping the module basically being separated into as many points as possible.
Okay, so PowerLetrics, that was the idea behind PowerLetrics. It essentially brings Linux up to kind of parity with the tools that Apple users and Microsoft, Microsoft users might actually have. So there's something like level parity across all of your platforms, basically, right?
Exactly. In an open source, so it's open source, everybody can use it, everybody can contribute to it. Universities are using it and giving us feedback. And that was really good. That was a really good step to have this. But then we went out and said, look, we have this great tool. You can do profiling, and you can. And people are like, yeah, that's great, but I can't have a tool running all the time that just to look at my processes. And so the way it's implemented is that it basically looks at certain kernel functions, kprobes, and so it doesn't have a huge overhead, but it has, because it wants to be very accurate, it has an overhead. And so we're going to like server providers and then operating system vendors, and we're like, look, install this, and you can see energy metric. You can have a little plugin. We wrote a little plugin for GNOME and KDE. And you can see, and people are like, yeah, that's nice, but I don't want to spend 1% of my resource usage just showing.
Yeah. Spend 1% to save 1%. Yeah.
It's sort of, something I like to say is you've got to spend carbon to save carbon, right? But so it turns out it's a great tool for benchmarking, for looking, but it's not as ideal for sort of running constantly in the background. And so we're like, okay, we heard the feedback. And then lucky enough, in Germany, we have something called the Prototype Fund, which I think you've also received money from.
Yeah, the Prototype Fund was what kicked off the Greenwave Foundation's reboot back in 2019. That paid me to build the first version of CO2JS and basically do a whole tour all around like a low carbon developer relations tour for like the idea of sustainability on trains, basically. Yeah.
So that's, I still have to do that, but lucky enough, they funded the continuation project of this, which was basically the lessons learned was we need something with less overhead, and we need something that somehow makes it more accessible, because just having a program running that dumps stuff into a file is nice, but it's not, people want it as simply as possible. So the second version is called ProcPower, and it's basically, it uses the same model as PowerLetrics. The only difference is it lives in the kernel. And because it lives in the kernel, we can do things. We can be more intelligent on the hooks we use. We can have basically close to no overhead. So I on my machines, I can't measure the overhead of the program running. It's so low. And what it does, it basically exposes your energy metrics through the proc file system. And anybody who knows Linux or Unix-based operating systems is that proc is basically your device list, right? So anything that comes in, your processes, your devices, anything sort of accessed through proc, right? And it's all files. It all appears to be a standard file. So if you look at, for example, the memory consumption of a process, you can go into /proc, the PID of the process, and then you have a mem whatever folder.
And PID being a process ID. So like, maybe I've got my browser, it will show me, I've looked for the PID for Firefox. It will say it's this big. You're doing the same thing for basically energy inside that kind of weird Linuxy, everything is a file mechanism they use for talking, to make things available.
Exactly. And through that, like a lot of things become far easier. For example, logging is just like standard log software, like Logstash and Log Rotate and what there is. They can open a file and pump it to go somewhere. So that's really easy. And the nice thing is, and that's sort of the caveat on top, and that sort of makes it really cool, is that if you look at modern computer systems, even desktop systems, everything's in a so-called C group or in a Docker container. And that's for security reasons. So if your process runs in a C group, it can't access resources from other processes. So if your Firefox, for example, downloads a virus, it runs in the C group of Firefox. So it can still destroy everything in the Firefox context.
But it can't do anything else, right?
But it can't destroy your email client's context, right?
Okay. So this is why. So when we spoke to the people at Firefox when they built the first version of the Power Profiler, they said, well, we found a way to make it work, but you would have to run your browser as root, right?
Exactly.
Which most people don't want to do, because that means one thing means it can just hose and just destroy your entire computer. Exactly. So that's the idea of C groups. They provide that bit of kind of like isolation, as it were, between different things.
Exactly. So they encapsulate basically the programs in their own C group. And you can create C groups on your own by shell, but not a lot of people do that. But the programs basically choose to go into a C group. So Firefox, when you start it, says, okay, I'm going to create my own little C group. I'm going to drop into that C group. And for that, I can't ruin the whole machine if I should have a security flaw. So it's best practice, basically. Yeah. And now you have this Docker technology, which builds on that and sort of isolates the process even more, right? It also isolates the file system through namespaces. And you can run Docker containers, which is now probably the default in software deployment. And there are also like Linux distributions that use Docker containers to isolate the process, to add strength on security. So what you have is, as you said, like if you run Firefox wants to know how much energy it's using. But because it's in a C group, it can't access anything from the operating system. It can't access any relevant, it can't access REPL, for example, or what CPU core it's been running on and stuff like that. So what we do is, because we have the kernel module, we can then expose this into the C groups. And then this Firefox can now go into that file system endpoint and see all the statistics, all the numbers about itself.
Okay.
So now suddenly Firefox knows I'm running with that amount of energy usage on the whole machine. It doesn't know the other processes, doesn't know how much those processes are using, but it knows how much it's using it on its own. And then that enables you to do cool things, right? So we wrote, for example, a WordPress plugin. It's an app for WordPress. You install it and suddenly you get like a sustainability tag, menu item. And now you can click on it and you see how much your WordPress, Apache, or whatever web server you're using, how much energy that's using. And you can then optimize and disable plugins or switch off cron or whatever. And you can do that. And we're also doing the same for Nextcloud. So I'm going to push that probably the next few days. And also for Django, right? So you have a Django app that you can install. And then in Django admin, you can see how much. And because it's all standard it's all standard files.
Reading a file, something which I know how to do. Yeah.
Exactly. It's very simple, right? So the WordPress plugin is really, really simple. It's just open this file and output the data you find in this file in the web browser through Ajax. And that enables for this to run securely on a machine and not to disclose sensitive information. Because what we do is we use a sort of windowing approach. It's not real time. We use like a second window, or you can configure it how you want, but the default is a second.
Okay.
And so what happens if you do some cryptographic operations or whatever, that's not exposed because it's all aggregated into that 1 second window. Which is totally fine for most things you want, right? It's not enough to do like high scale optimizations, right? Seeing if this call is better or that malloc is better or whatever. But it's good enough to give you a good overview. And so that's sort of ProcPower, right? So ProcPower can sort of give you the energy from a kernel perspective and sort of makes it a first-class citizen, like memory usage, disk I/O, network I/O, whatever you look at. CPU utilization is often shown, even if the value of CPU utilization is not a very good value to go by, because modern CPUs sort of do everything else but adhere to the CPU utilization. But it becomes a first-class citizen and you can act on that, right?
Okay, so if I can just try and summarize to make sure I understand what you're saying. So previously you had PowerLetrics, which was, it could give you numbers, but you had to know to run it yourself, and you had to kind of set up a bunch of things. This is almost something that can run in the background. So just make something readable the same way that programs know how to read data anyway. So you're essentially provided the same kind of ease of use or ergonomics for people working with this kind of stuff. And now you've got something that theoretically anyone who's running a WordPress website, they could install themselves, and they either might get some numbers, like if they're paying for, say, a hosting provider, they'll get some numbers there, but they could get would they get better numbers if the person who runs the physical machines had this running to provide, higher resolution information or something?
Yeah. So ideally, obviously, you're on the host OS operating system, right? So if you look at how modern data centers work, right, you have like one machine with thousands of VMs running on it, or hundreds. And obviously, if you run ProcPower on the host system, it's going to give you better numbers, right? Because it has the complete picture. It has like the heat of the CPU. It has all these factors. And it has REPL and whatever, right? It also works, because we build a model, right? It also works in a VM. So if you get a VM, you can also run ProcPower, but it won't be as accurate. The model just doesn't perform as good because it has less input data. So obviously our aim is to get hosting providers to install this and to be like, oh, look, we're a sustainable hosting company, or we claim we are, or we want to help sustainability. We've installed this kernel module, and now every user using us in a VM, in a Docker container, however they use it, they can then get the energy values of the processes they're running.
Okay. So flip side, if I'm a provider of these services and I want to kind of differentiate and say, here's how you can, we will help you be transparent about how sustainable a particular website or an app might be. We'll give you the hooks so that you're able to kind of share this information in like API requests or a web page. So just like that WordPress thing you mentioned, it sounds a bit like I could have a number in the same way that WordPress says this page took this long to load. You could say this page took this much energy to be available, and that's something that would be like the proposition for me as a hosting provider who wants to host other people's WordPress websites. That's the thing that you'll be able to do with that, right?
Exactly. So making it transparent, right? So the one thing we really need, I think, is transparency, right? We've been, there's still no disclosure of like resource usage or a lot of things. This makes it really easy to disclose this information in a secure way and give you the transparency that I think we should be claiming, right? We should be asking for these numbers. And now you can't have the excuse anymore that there's no way of getting to these numbers.
Okay. So even if let's say I'm working with a very, very large cloud provider that might be the market leader, and they never ever release any energy numbers, I could use this and say, well, I'm using the figures from, say, Amazon, and they're going to be bad figures, but I'm using this, and I could speak to my rep and say, hey, either person at Amazon or Microsoft or Google or Hetzner, I say like, hey, I want I'm already trying to disclose numbers because maybe I might want to create a software carbon intensity score for a web page load or API request. But you say like, I'm already doing this. If you were to do this, I would have more reliable numbers and it would make me much more credible as well. Can you please do this? And as long as there is someone who has access to a bare metal machine somewhere, that's possible, right? Yes,
exactly. So you can run it in the VM and get your numbers. We also have like a machine learning model we have a statistical model called Cloud Energy that can do the same, that we use, for example, to estimate the energy usage of GitHub CI/CD pipelines. Some people might.
That's how you do it. I realized that because we use it ourselves. I was like, I know Didi and I trust them enough to know that they're using something, but I'm not sure what the piece of software it is. So it's Cloud Energy under the hood. That's giving me my numbers.
So Cloud Energy is basically what gives you the numbers, and that's a statistical model we trained on the spec power. Sorry, so it guesstimates the machine and then it takes CPU utilization. But you could also now run ProcPower to get these values
and get much more accurate numbers if you have access to the underlying hardware.
Exactly. So it's exactly as long as you have access to certain hardware counters.
Okay. I now understand why you were so excited about this, particularly in the context of like Germany and Germany having a whole thing about certification and being and offering things like and offering different kinds of certification schemes, and people talking about things like the Blue Angel system and everything like that. Because I've done work where people have said they're in a large organization, like we want to ask our developers to basically take more responsible steps about the energy usage that we know is happening, but we don't have an easy way to make this stuff visible. And we've looked at like, okay, what guidelines are out there? Should we ask people to get certified? And like, we see the whole Blue Angel thing, we feel like, wow, there is quite a lot of steps I might need to do to begin with for that to be my starting point. So it feels like this might be some credible thing I can use, which doesn't where I don't have to jump straight into certification, for example.
Yes,
if I want to at least introduce some minimum standards here, then.
Exactly. So you can start looking at software. You can start. So what we always say is like, you have to make sustainability a first class citizen, right? As does CPU, as all these other metrics. Like we have to start thinking sustainability too. And coming right to a point before that, it also has a big advantage to the providers, because currently the providers give you a VM and they just sort of guesstimate what you're going to do with it. But if they can see how much energy each VM or Docker container is using, they can do dynamic charging, because power is basically the big money sink, right? Like they have to buy the hardware, then the hardware's there, and then basically it's cooling and power that are the main costs of a data center provider. So hopefully, in a dream world, we'll have dynamic pricing, right? We'll have this VM is now cheaper because the sun is shining and not a lot of happening in the data center. So go on, and that's another sort of building block, I hope, in this whole construct.
And let's say I'm sharing a data center with a bunch of people who are doing like crypto mining, right? We would see, they would show up, they would be way more visible straight away to say like, it's those guys, it's their fault, not my fault right now. Yeah,
exactly. Because currently data centers they've got maybe rack level resolution, but on a rack you've got thousands of customers doing stuff, right? So they look at utilization, they look at some matrices, but obviously that is like another thing, right?
Oh, okay. So I'd never really considered it from that point of view, that this does give a degree of visibility. And because you said there was the kind of windowing thing, that seems like it. So basically, what I've learned before, because there's a project in the Green Software Foundation called Real-Time Cloud. We'll share a link to it in the show notes. And one of the key things we found, one of the reasons there were people in large companies pushed back. They basically said, we can't share these kinds of metrics, because these kinds of metrics at high enough resolution end up disclosing information that allows people to use it as a way to make a cyber attack, basically. Yes. Like that's a bit of a summary, but like that's kind of the thing. And it sounds like you've by having this kind of windowing trick that defends against some of that. So you can provide these numbers and you can provide them in a mechanism that allows you to optimize without having to say that, we can only take a sample once every minute, for example, or once every hour, yeah?
Exactly. So, obviously one big problem is that you can sort of guess what other people on the host are doing if you have fine enough resolution, right? And through the windowing approach, we sort of neatly avoid that problem. Cool. In a very easy solution.
Nice. It's got a cool name. I think it's like Spectre or something to do with bears or something like that. I forget the name. I'll have to add it in there, because this was actually
the RAPL side channel attack.
That was the one. Yeah, so that's it's a really esoteric thing, but it has been used as a blocker, and this seems like you do address that blocker issue.
Yes.
Okay, cool. Well, I didn't know that. That sounds quite handy. So before we dive too deeply into this, we did talk a little bit about like certification, and you told me you're calling from Germany today, right? And Germany, as far as I'm aware, it's one of the only places right now which has it's the first country in the world with a certification system for software. And I understand that this is something that you folks have been involved with. So maybe you could talk a little bit about that. And then I might have a couple of full-on questions for this, because when I've seen certification, it tends to be a thing that happens once a year for one version of this. And like, I work with software and it's changing all the time, for example. But before we get there, let's just talk about, okay, so you're in Germany. There is now a Blue Angel certification for software that some organizations are now starting to adopt for their software, right?
Yeah, exactly. So Germany has a long history sort of in like environmental. I feel like that compared to other countries, we have a very strong Green Party, for example. The Green Party was in government a few years ago. So there's this long history in anti-nuclear, like Germany has no nuclear power. Well, I think they shut off the last nuclear power plant a few years ago. So Germany is very eco-conscious, let's say, right? Despite being a car building company and country. So, but there are lots of people in Germany that sort of, and so are the governments, some of them. And so Germany has this environmental agency, and they established the Blue Angel 50 years ago or whatever. I don't know how long. And so it's sort of an eco label by the German government that says certain criteria has to hold for the product that has this eco label. And in Germany, it's very famous for toilet paper. That says the toilet paper has to be N% recycled. There's no chemical dyes allowed, or I don't know, like there's loads of criteria. And so people buy toilet paper with the Blue Angel to say like, okay, I'm going to contribute a little. And you find it on water, on all different things, right? You see the Blue Angel. And so 2000, the Umweltbundesamt, or the German Environmental Agency, sort of saw that software is contributing huge amounts of resource consumption, and had a project where they developed sort of guidelines on how to certify software. And in the 2000 version, it was very much sort of on a desktop environment thing. So Ocula, the KDE PDF reader, was, for example, certified in the 2000 version, being a desktop program. And it's sort of, the Blue Angel gives you sort of guidelines on what software should be. It should be maintainable. It should be like you should have modules. It should be like documentation, updates for free, no advertisement. So it has all these let's say call them soft, right? It has all these aspects of maintainability and letting the software run for as long as possible on old machines. It had this very innovative idea of the software has to run on a 5-year-old machine, right? So especially with mobile devices, most of the environmental impact is in production, right? So the most eco thing you can do is keep your phone the longest possible.
As long as you possibly can. Okay, yeah.
Because you can't optimize apps as far as, like, even if your phone runs all the time on one app would run all the time, it wouldn't use as much energy than has gone into producing it. Or a CO2 equivalent, right? So the Blue Angel was very visionary in that sense, that it said, okay, it has to run on a 5-year-old machine. And a decision they made, which I really like and I think is really important, they also added measurement. So this was sort of contested and this was discussed, and they were like, no, we have to measure the software to know how much resources it's using. And it's not allowed to get worse over time, like N% worse over time. So you're not allowed to introduce a new feature that will suddenly double the resource consumption.
Okay.
And so that was a really big point that I'm really happy they added. That they said, okay, we have to measure software. We have to measure the energy consumption of software. Unfortunately, the 2000 version of the label left out a lot of the real world
how to measure this, right?
So it left out. So it did specify how to measure it, but it left out applications that were then happening, like like websites, server client.
Okay.
It couldn't do server client. So there wasn't wide adoption at the time. And when we looked at it, when we started green coding, it was like, okay, which desktop software do we really use that is just like a desktop software that's not interconnected with the world anymore? And lucky enough, 2025, there's a new version out there now, which can do server client, which can do some of AI, which we're still talking about it. So lucky enough, we're part of the consortium or part of the people that they talk to get details on this. And now we can sort of benchmark, we can get certification for all types of software, for websites, for all types of apps, and now the 2025 version is really something we can apply to a lot of things. And from the beginning, when we started green coding, we were like, this is a great label. Has great ideas. Like the people that created this label had really good ideas and were really ahead of their time when they created the label. So we modeled the GreenMetrics tool very much along the Blue Angel lines. So we have these like phases: the install, the idle, the runtime, uninstall phase, for example, which comes from the Blue Angel.
I see. Okay, that explains why you have that now. Okay, thank you.
Exactly. So that was because Arne and me think the Blue Angel is a really sweet thing, and really smart people have done great work. So we should copy or use their work. And so when the new label came along, obviously we were like, okay, you can use the GreenMetrics tool to certify So pretty much every measurement you do in the GreenMetrics tool is Blue Angel ready, let's say, right? You have some boundaries. You have to repeat it 10 times. You need but all the components are there to just plug in. And then we have an exporter that you can use that gives you all the Excel sheets, because it is an official label. It's by the German government. You need an independent auditor to come along and look at your measurements, look at your data and verify it and say, okay, this is properly done.
Yeah.
This is. And then you have like a independent certification body, the VAL, which is like a non-profit that certifies you and gives you the label. And so the measurements have to be good. It has to make sense. It's probably German accuracy, right? It's very like, you have like huge Excel files you have to fill in.
They're not doing much to dispel the stereotype there, yeah.
Exactly. But, or open, you can also use OpenOffice or LibreOffice. But yeah, so you have all these steps. And so we said, okay, we really want to help this. We really want to do this. So, we have this like exporter that you can measure anything and you can get like a Blue Angel certification.
Okay. So let me check if I understand. So you folks have been working on one piece of software called Green Matrix Tool. This is an open source project. It's like, AGPL or MIT or some license that means that I don't need to know you. I can download this or I can work with people, and that allows me, as long as I go through the kind of technical steps to kind of set up maybe a browser and maybe a server, I can basically simulate the typical conditions of me using something like this, and that will give me numbers. And that then, so if I wanted to maybe say, so that's what the Green Matrix Tool gives me. And the idea would be that, let's say I'm working on some software and I want to be certified because I want to sell to, say, public sector in Germany, and they all require this. I would use this software or find someone who's making the software available. I would get them to maybe set up a test in the same way that my software has maybe a test for end-to-end integration to make sure that the browser does the thing it's supposed to, we think it's going to do, for example. And then once I've got these numbers, they'll then need to present that to an auditor who then sends it to that agency. Maybe you could expand on that part there.
So the Blue Angel has multiple points, right? So it has a certain requirement on how to measure your software, and it has to be representative of the average usage of the software. So we call it a usage scenario. That's basically how is the software used, right? So if you have a website, it's like, okay, click here, fill out this form, send a request, do this. And so we just certified Nextcloud, for example, and which is a Google Docs or Google Drive alternative. So you can have like email, you can have video conferencing. It's got all the calendar, it's got all these components. And so we were like, okay, what's the standard use case of your tool? It's uploading a file, it's downloading a file, it's collaborating in their talk solution, it's creating a calendar event, creating a contact. So you sit down and you sort of, mostly from like the data that people have, you sort of look at the standard usage scenario. And then what we do is in the Green Matrix tool, we sort of orchestrate how the software is really run, like with the Redis, with the database, with the browser, with all the different components. And then we can benchmark it. And then you have to repeat it 10 times to get like, to have a statistical proof that that's really what's happening. And then you fill in the Excel sheet and you have to fill in the other factors like where's the documentation, are updates for free. There's a long list of these things, but they're mostly like put in your documentation link here. Is there advertisement? Yes, no, right? So you click, yes, that's all the part. And then you take that bundle and you hand it into the auditor. And the auditor then has to be independent. So it can't be the same person that does the measurements. It has to be an independent person. And they're over 20 audits. So I'm an auditor, for example. I could audit Blue Angel software, but lots of people in the sustainability space are auditors in Germany.
Okay, so they're not doing the measurements. They're just reviewing the measurements.
They have to be different.
Okay,
they
all right.
have to be different. And they have to be appointed by the German government. So you have to go through some tests and you have to know what you're talking about.
But are you competent? So therefore, you're just not some rando Joe. Okay.
Exactly.
Or Jane. Yeah.
Yeah. Exactly. And then you're an auditor, then you get the paperwork, you check everything if it sort of makes sense and then once the auditor says that's okay, it then gets handed off to the RAL, which is by the German government. And they say, okay. And they don't do a functional test. They sort of look at that all the paperwork's okay. And then you get the Blue Angel, and the Blue Angel also has like a time factor. So as I already mentioned, your software is not allowed to get worse over time to a certain degree. And so you have to reevaluate. And what we do, for example, with Nextcloud is every commit or every release or commit, we reevaluate. Right. So we take the Blue Angel test, we reevaluate, and we say like, Nextcloud, look, over time, you're getting really bad. or you've added this new feature, you're getting worse. And you get these like really cool timelines where you can sort of see over time how programs sort of get worse and worse and worse, or better, in their resource usage, which is really important because if you look at, I always like to talk about my email client. Like the email client I used when I started computing, was this like terminal-based text that used close to no resources. It would download everything via POP, and it used close to no resources. Now my email, I don't know what it does with AI. I've got a program running on my computer, and it uses loads of resources.
It's like software. It's like a gas. It expands to fill the container. Yeah. Exactly.
As Max Schulze from the SCI, right? You always add new features. You always expand. You always make it more and more. It's one of his big points. And that also happens. So you sort of have to take that into account. That's what we do with continuous measurements, right? You continue measuring your software. You make sure that it doesn't get worse over time. Or
I see.
Only
so
to
just
a certain degree, right?
And that's built into the certification process, basically. So, like, you're not allowed to be worse than 10% worse over a year, for example, something like that, right?
Exactly. But that's exactly so. But the certification process is beginning and end. I think you have to remeasure after a year. I'm not sure. But we obviously advocate for continuous measurement because if you notice a year later, oh wait, look, we're 50% over.
Yeah.
It's a little bit late. What you want to figure out, okay, I've now used this library, I've now used this technology, I've now changed something fundamental, or I've added this feature. And now suddenly my resource usage jumps 10%. And so you have to catch as early as possible.
Oh, I see. And like, that's plausible if you have any kind of continuous integration where all the tests are run on a change. It sounds like you would just run these tests like other tests, basically. So you would would not pass or would fail. So, would pass certification, would fail certification by when you come around next year, for example.
Coming back to this point that we have to make sustainability like a first-class citizen, like security, like tests, like functional like properties. So sustainability has to become like a gate that you have to pass before you can release your software.
Okay, I'm really glad you kind of gave that outline, because one thing I do know that I'm not totally kind of like involved in, but I see, so in the Green Software Foundation, there is a whole, there is some work, there was a blog post shared, I think a couple of months ago, about exploring something like certification. And it sounds quite similar to what you're saying. So I think the thing they ended up moving for was, rather than saying this software is sustainable, you base the emphasis about it's about a certificate of disclosure, making the information visible so people can make a decision about it. Because saying something is sustainable is straight away, that's kind of subjective. But it also sounds like with the Blue Angel thing, you've got the same approach where we need to at least demonstrate that we are measuring things and we are disclosing these things. And then that's what it's about, rather than saying this is definitely green software, because that's possibly a subjective thing. And we don't really know enough to know what counts as green in different sectors so far.
I would even argue, is there green software?
Is it possible? Yeah.
Is it possible, right? When like, as soon as you use resources, is it green, right? So yeah, so the Blue Angel doesn't compare. So it's a very big thing that you cannot compare software against each other. So you can't say this software and this software, this is greener or this is more environmentally friendly. And the Blue Angel is very much against that. It only states that the producers of this software, they've thought about it. They've sort of taken things that are generally agreed to foster greenness. Like, is the software maintainable, right? Which makes it clear, right? If the software can run it on a 5-year-old machine, you don't have hardware obsolescence. So these generally agreed parameters, it just states it abides by this. It doesn't say this software uses less energy than another software that doesn't have the Blue Angel, right? You could easily certify something that uses a lot more energy than something comparable. Talking about my email client again, you could certify an email client that uses far more energy than the Alpine I used to use 20 years ago. But it shows that the people that produce this software, they think about these things, right? They've committed to certain aspects.
Okay, gotcha. So there's, if nothing else, there seems to be like in the very least, a baseline that has been declared and disclosed, such that you can check something against that baseline going forward then. So that's like one of the key ideas behind this part here. Okay. All right, so that's the full fat super certification thing. And then the earlier project, ProcPower and PowerLetrics, where this was like making some of these numbers available so that you can begin working towards that. Exactly. All right? Okay. Thank you for holding my hand through that process, because every single time I've looked at the whole certification thing for software in general, I've always felt, oh, wow, this looks really, really heavyweight. And when I did look at this stuff before, like, well, I wasn't sure, like, it's aimed at desktops. But that doesn't matter for me if I'm building a website, for example. But based on what you told me, the actual, like, when you describe things like having a usage scenario, that sounds a little bit like a user story. Or if you're using a website, if you're developing sites, you might use tools like Puppeteer or something like that to drive a browser to say, I'm going to this page, I'm filling out this form, and then I'm downloading something. If I can script that, that's something that I've got the starting point for all the things I need for certification, basically. Exactly.
That's literally what we do. Like, if you look at the Nextcloud case, obviously we've also certified. I don't know what to talk about Nextcloud, but that's the most well-known software suite, right? We've certified loads of other tools already. But that's exactly what we do. We use Playwright for Nextcloud. We start Firefox or Chrome, depending. We support both. And then you can basically be like, okay, click on here, do this. And then we measure the backend, the database, all the different components. And we can then give like a qualified number to certain.
Okay. Thank you for this. I've just realized I was at a conference called Green.io Munich, where I believe there was someone on the auditor side talking about what they do and what they see. And like, this makes it a bit easier. This also, I guess, makes you realize that, I mean, this is probably a nice segue. I mean, I was at Green.io in Munich. There's a Green.io in September, I think at the time of recording, where our director of operations at the Greenman Foundation, Hannah, is presenting on a project we have called Carbon.x. But I guess as we're coming up to time, I just wanted to talk a little bit about events, because I know there's Green.io, which is in Paris, which is like it's probably one of the largest sustainability in software event that I'm aware of, and that one that I recommend for people if they're going to be in Paris. But as I understand it, this is something else you've been doing, is running something a bit like this in Berlin as well. So you don't have to jump on a sleeper train to Paris to kind of meet other nerds, basically, right?
Exactly.
Sustainability nerds, I suppose. Yeah.
Yeah. Obviously, we're different to Green.io, whereas Green.io is a great conference. And I think Arne gave a talk in the mini conference. So 2 years ago, over 2.5 years ago, we got quite frustrated with the sustainability tech space, as that there were lots of people going around and sort of with this doomsday scenarios, right? We're all going to burn in hell. And then they were giving like abstract recommendations. You should use whatever technology. At the time it was location time shifting. And we're like, so yeah, that's good, but where's the numbers? Like, where's the project that proves this? You had all these people going around sort of on this high level, giving you these and now I see that with AI a little bit, that you have all these people that are like, oh, AI is going to kill us all. And I'm like, yeah, might do, but then you like, okay, what can we do to tackle this, right? Yes, it's bad, but I'm sorry to say AI is here to stay, right? It's not going to go away. So now we have to sort of think about how can we make this more sustainable? How can we have an honest and fact-based discussion? And at the time, there wasn't really something out there. There was sort of the tech, let's say the high-level tech community, and there was the scientific community, which has great conferences. But a lot of the papers are so specific to like this this one chip. If I change this malloc algorithm, I save 2% energy. And while that's really important, it wasn't sort of the applicable thing that most software developers need. And so, like, as I said, I come from a background as a CTO, right? And I remember saying a few years back, we had this like algorithm, and I'm like, how much is it going to cost us to optimize this algorithm? Or how much is it going to just cost us for this new machine to fire up and like. So what I need easy solutions, right? As a CTO, I can't go into the nitty-gritty details, and I'm scared enough already as it is. I know climate change is bad. So I need like simple solutions, and I need success stories from other companies that have shown that this works, right? So Arne and me, being two nerds, were like, okay, let's start a conference.
Okay.
because there wasn't something out there at the time. And so the first iteration was in Munich last year. I think you were there. I can't remember.
I was not. I've never been to an ecoCompute. I have not had that pleasure yet.
Sorry. Yeah, exactly. So we started the ecoCompute last year, and we're totally caught off guard on how much, like, we shared it on LinkedIn, and we were like, okay, if we get a few people, it's going to be good. And it was just overwhelming how many people joined, and also the quality of the talks. And so this year we're doing it in Berlin. We don't know where we're going to do it next year, but it's still going to be Germany. Hopefully, saying that, probably. Let's keep it by that. And the idea is to have a conference where, like, people give you the numbers, and that's the thing we ask when people hand in a talk. It's like, show us the numbers. Like, it's nice that you have this idea to put data centers in coal mines because they're nice and cold, but have you done it? Right? Have you done it? Show us the numbers. And that's basically ecoCompute. We have loads of different tracks. We've got like a hardware track for a data center track, a software track, AI. We've got great workshops. We have, like, if you want to learn about the Blue Angel, we have a Blue Angel workshop where you can learn how to certify your code with the Blue Angel. And as a fun fact there, the German government has now given a grant that open source projects can get the Blue Angel for free.
Oh,
because there is some certification cost in, it's not a lot of money, but it is money. And some, like, as an open source project, we all know you don't have a lot of money, especially not for Blue Angel certification. And so now the German government gives you a grant, and we really want to use that to sort of help open source projects get the Blue Angel. So there's a Blue Angel track. There's like a data center sustainability track where, like, data centers can talk about where they put their compute and how they optimize stuff.
How to avoid running on-premise gas turbines to run your data center. All right.
Exactly. Run close to a wind turbine, right? We have Linux optimization, AI. We've got all that, like, we have like a big meet and greet social thing. And exactly. So it's in Berlin. You can go to eco-compute.io and find all the details. And we also have a promo code if anybody wants to save some money. If you use environment minus variables, we'll also put it in the show notes.
Okay.
Chris, you said you're going to put it in the show notes.
I will put this in the show notes, yes. This is in November, you said, right?
Yes, exactly.
Okay. All right. So there's a bit of time. So this is probably going to go out probably in the end of September or very, very early in October. So people will have at least a month to know that it's on their radar before they have to make a decision.
It's 13th and 14th of November.
Okay. And this is one of the places where people, if they wanted to learn about or, like, dive more deeply into some of the things we've been speaking about, I presume you're going to be there, right?
I'm going to be there, exactly.
You better be there, surely, if it's your conference, yeah?
I'm also going to give a talk about ProcPower and sort of how to use ProcPower and how to integrate it into your machine, and sort of go into more details on that. And the program is online, so you can check out all the talks we've got. And
cool.
Great to see you.
All right. Well, hopefully that should help give us something to, I don't know, look forward to, other than it just getting dark and grey and depressing in Berlin, as the summer appears to have been switched off now over here, basically.
You will leave with great insights on how to, hopefully. So the idea is that you leave with, like, knowledge how to optimize, and not
something you can use, right?
Exactly, and not leave with a doom and gloom as you do from lots of sustainability conferences. You sort of leave with a fatalistic worldview that we're all doomed, and that's definitely not what we want.
Well, I'm all in favor of having something positive that you can act upon when thinking about this, even just to kind of work through, I guess, how you're feeling about the climate crisis and everything like that. Because, just look at the news, the kind of meme where you just, like, gesture. That's what it feels like, what you kind of need to do at the moment, actually. Well, Didi, I think that's taken us to time. I really appreciate you talking me through what is effectively a very, very technical topic, but I think is actually quite important for people who do want to know if they're improving things or rather than making things worse. And I have to say, I'm looking forward to ecoCompute, not least because, I'm presenting there as well, actually. So, yes.
This time round.
Yes, this time I will be there. All right. Well, Didi, I have to say I'm gonna leave you, but I hope you enjoy the rest of the farm and say hello to the animals for me. And looking forward to seeing you at ecoCompute, if nothing else. Take care, mate.
Thank you very much. Take care.
Cheers.
Bye-bye.
Bye. Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.